Here we're asked to find the derivative dy dx of an equation given to us. The difference between the equation they're giving us now and the equations we're used to seeing is we've got x's and y's mixing together throughout the equation. We don't have a nice clean y equals some equation with a bunch of x's in it, which is what we've been used to doing. So what we're doing here is we're going to do a process called implicit differentiation. And so the way implicit differentiation works is you kind of wrap your equation in a set of parentheses and you're going to ddx the whole equation. So you're sort of taking the derivative of each one of these chunks with respect to x. And so my process when I go through this is I say every time I take a derivative I get extra stuff. And what that extra stuff is going to look like is it's picture sort of this box behind that D on the top layer there, and I'm going to fill that box in every time with the letter of whatever I took the derivative of, and that's going to give me my extra pieces every time I do this. So I start off and I'm taking the derivative of x squared here. So the derivative of x squared by itself would just be 2x. I took the derivative of an x, so I'm going to get a dx over dx. Again, I filled that little box in with the letter of whatever I just took the derivative of, and that's how these dx dx's and dy dx's start appearing for us. So I then go to this next equation here, which is 2x times y. And the thing about this is two things being multiplied together, and so what we're looking at right now is going to be a product rule for this section of the equation. So remember as you go through all of these types of problems that product rule, chain rule, quotient rule, all those rules still apply. Generally in these problems they only really use the power rule and the product rule, but you can't discount the fact that the other ones could be there. So we remind ourselves of the product rule, which was fg prime plus gf prime is how I have it memorized. So I label the first chunk f, so 2x is going to be f, and then y is going to be g, and I run through my product rule right now. So the product rule first says go grab f. So I go grab f, 2x. I then go grab the derivative of g. So the derivative of y by itself would be a 1. I took a derivative, so I get extra stuff, and this time it would be a dy dx because I took the derivative of a y, so I'm plugging that y into that little box up top there. So I've got my f and my g prime, and now I need to do plus g, which is y, and then f prime, the derivative of 2x would just be 2. I took the derivative of an x though, so I get a dx dx. Again, filling that little box in right there. So now I'm done with my product rule, and I move on to the last piece here. So I take the derivative of 3y squared. That would have been 6y, and then I took the derivative of a y, so I get a dy dx out of that. Again, filling that box in with the letter of whatever I took the derivative of. From here, I always do a cleanup step. There's going to be some extra things and some rearranging that you want to do just to make it easier to do the next bit of algebra that we end up having to do. So in the first piece, this dx here, I can cancel out. It's like having a 5 over a 5 where you can just cancel the two pieces. So I end up with just a 2x in that first piece. Plus, and then I've got my 2x. I don't really need that 1s, and then I can keep the dy dx. So I just got rid of that. Plus, and then I'm just going to rearrange these two numbers to make them more clear to read, which would be 2y. And then again, I don't need a dx over dx, so those are going to cancel out. And on the right-hand side of the equals, I have a 6y, and I still have a dy dx. At this point, what we're trying to do is get these dy dx's by themselves. We're trying to solve for dy dx. That's how we get our derivative out of this. And so the key to this game here at this point is taking every term that has a dy dx and making it on one side of the equals, and every term that doesn't have a dy dx needs to stay on the other side. So again, this part of the process is always the same. You're going to isolate the pieces with a dy dx on one side of the equals and the pieces without a dy dx on the other side. And so in this situation, the only move I really need to do to make that happen is moving this 2x dy dx on the left-hand side here. So subtract 2x dy dx, moving the whole piece over to the other side. And then that's going to leave me on this left-hand side with just 2x, and then those cancel out, and then I end up with plus 2y equals my 6y dy dx minus 2x dy dx. The reason that we get everybody on this right-hand side here to have a dy dx is now that everyone has a dy dx on the right side, I can go ahead and factor out, I can pull a dy dx out of each one of these pieces up into the front. And so that looks like 2x plus 2y equals, and then I pull my dy dx to the front, and that leaves me with 6y minus 2x. I'm now just going to go ahead and move this work over here so we can see the rest of this algebra. So I'm just transferring this up as 2x plus 2y equals our dy dx that we factored out times 6y minus 2x. From here, again, the only move we need to do, we're just trying to get the dy dx by itself, so we're just going to divide both sides by 6y minus 2x and divide by 6y minus 2x. And so out of there, what you'll end up seeing is 2x plus 2y over 6y minus 2x equals dy dx. I always tell people at this point, especially on a multiple choice math test, I would go over and look and see if any of my answers match. And we can see that our answers aren't quite there right now. And so what has ended up happening is they've done a little bit of simplification on this. And what you can see is on the top here, I've got a 2 in everybody, and on the bottom here, I have a 2 in everybody. So they pulled a 2 out of everything. So x plus y out of the top, pulling a 2 out of every piece. And then out of the bottom, when I pull a 2, I end up with 3y minus just a single x equals my dy dx. And so those 2's end up canceling out, and that right there is what you'll see is going to be your final answer, the x plus y over 3y minus x. So again, the process here is take the derivative of each piece, and every time you take a derivative of something, you fill in that box up there behind the d with whatever the letter is you took the derivative of. And then clean up your problem, isolate one side with all the dy dx pieces and the other side without it, and that'll allow you to factor out a dy dx and solve for it as its own variable.